All right, so today what we're going to be doing is continuing our looks at measures of spread. We've got all your data is here. In order for us to work with this data, it's a lot easier if we have the data sorted. So we've created a table with our score values, 88 all the way up to 110. So that's going to be our range of data. What I'm going to ask you to do is just to go through and fill out how often frequency occurs for 88. That's just a once, which gives us cumulative frequency of 1. And 92 occurs only 1, so now our cumulative frequency is 2. I'm going to pause the video, have you go through to total up this table. It's good practice just to go through to get that done, and then once you're done, hit the play. So pause the video right now, and then you can come back, and once you've created your table, check your results, and then we'll continue with the video. Okay, so we're back, and hopefully you've gotten the same results. Notice that this is divided into 2 sets of 10, so I've got a total of 20 data points, and my cumulative frequency sums to 20, so that's a kind of a good indicator that I have checked off all my points. As you check off your points when you've done your 88, it's kind of a good idea to kind of make some sort of a check, just because it's very easy to end up missing a data point, and then that really affects your results. So we're asked, one means of measuring central tendency is looking at range. Range formula is given as x max minus x min. In this case, our x max is, so our range for Janet's scores is our maximum value is 110. Easy to do because we've sorted this data in order, and then our low score of 88. So this generates a value of 22. Range is one means of measuring central tendency, but it's not necessarily super effective. It can have it can vary widely. I can imagine someone having a terrible game, or someone's test score. They were really sick one day, so it's not always the best measure of central tendency. So what we want to look at today are some other means of measuring central tendency. So we want to look at quartiles and interquartile ranges. So the idea behind quartiles is to break everything up into quarters, right? We take $1 that breaks up into 4 quarters. We're going to take our data set and we're going to break that up into, instead of just halves, when we find the middle point, that's our median value. What we want to be looking at instead is taking that half, our median, and breaking that into half again. So that's going to be breaking it up into quarters. And then we call each sort of section, this here is going to be our first quartile, our data falls inside the second quartile, third quartile, and then our highest point, which is the fourth quartile. So let's just read this. Quartiles divide a set of ordered data into 4 groups with equal numbers of values, right? So it's the number of data points that we're talking about, just as the median divides data into 2 equally sized groups. So the 3 dividing points are the first quartile, Q1. So this is our first dividing point, our second quartile, which happens to be the median. And so it's also called the second quartile, and then finally the third quartile. That's here. So those are the 3 dividing points. And if we say that quartile 2 is the median of the entire set of data, right? That's the entire set of data. The first quartile is the median of the first half of data, and then the third quartile is the median of the second half of the data. Continuing to read, recall that when there are an even number of data, you take the midpoint between the 2 middle values as the median. So if I have just 2 data points, a 1 and a 2, in between that is going to be 1.5. So if our number of data points is even, we end up having to take the middle of the 2 middle values. If the number of data, or the average of the middle two values, if the number of data below the median is even, Q1 is the midpoint between the 2 middle values in this half of the data. And if Q3 is determined in a similar way. Yeah, so if it's even, then it's going to be the midpoint, but it's going to be between the two middle values. But of course, if it's odd, it's just exactly that middle value, right? So if I had a value of 1, 7, and 18, those are three values. This becomes my median. If I had a value of 1, 7, 18, and 33, I have an even number of values, 4 values. So I have to take the two middle values and take the middle of that. 7 plus 18 is 25 over 2. So now my median for that would be 12.5. That's all that's indicating. And I think you guys know how to calculate the medians. So we're giving an example. We want to find Q1, Q2, and Q3 for Janus golf scores. Well, Q2 is the easiest. Q2 is the same thing as our median. We've already done this many times. So remember, we have a total of 20 values. 20 scores, so this is an even number. So the median value will be between if I take 20 divided by 2, 20 divided by 2 is equal to 10. So it's going to be between the 10th and 11th scores. So I need to go find what the 10th score was. If I go back on my previous page, my cumulative frequency, my 10th score is here. So that was a 96, and my 11th score is a 100. So my two scores that I'm interested in are 96 and 100. It's got to be in between those two values. So I take my 96 plus 100. Those are the two scores, the 10th and 11th scores. I get the middle point of those, and that gives me a value of 98. So my Q2 is equal to 98. Quartile 1 is just the median of the first half of the data. So I'm just going to write that. It's the median of the first half of data. Right, and we have 10 values in the first half of the data, an even number. So 10 divided by 2 is the 5. So I'm looking at so I look at my 5th and 6th values or scores. So I have to go back and find out what was my 5th score in my table. Her 4th score was a 94. So her 5th score and her 6th score and her 7th and her 8th and her 9th were 95. So her 5th and 6th scores are 95. These are the same values. So, I mean, it's just going to be 95. Technically, it's 95 plus 95 over 2, which, of course, is just 95. You didn't need to do that. It's just, had those values been different, that would be how we would apply it. So 94 represents her Q1, or that's the first quartile. In a similar fashion, our quartile 3 is the median of second half. In other words, it's we're talking about but the scores 15 and 16. Looking back at my data, where do the 15th and 16th scores occur? 15th score is this, and my 16th score is this. So it's 104 and 105 are my scores. 104 and 105. 104 plus 105 over 2, which is 104.5. So that is my my quartile 3 value. I will pause and then continue on the next video because I don't want to run out of time. Or pause, I'm going to end it. And